Oh, good. I don't want to have to preview stuff. I just want to stream. All right. Let me just check something out. Just want to make sure this is working. Sure, the stream is going. All right, so I want to. Yeah, I just want to look at this multimodal Llama 3.2. And by the way, this is a good article. This guy did good. I'm going to follow him. Uh, see if he is on Twitter or something. That's all right. Um, breaks this down well. Um, and while I'm going to go along that, I'm also going to. Let me just see. So, hmm. Sometimes the easiest way for me to understand stuff is just getting the shapes of. Okay. So this third actually processes all patches globally, similar to a standard VIT. So is that what I'm in right now? Hmm. What I'm a little confused about is this. Oh, it's tiling stuff. So I haven't really seen this approach before, but generally speaking, especially for UI type stuff, it's probably pretty good. Well, then I'm fully confused why it's tiling. So it does it. That's interesting. That's what. So it uses a apply class embedding. Wait. So it pops on. So the way it's integrating this information is very different than I could have ever guessed, to be honest. Well, the class token's standard. It's very standard um, for adding the gated positional embeddings. Okay. Okay. Not sure exactly. Okay. It does seem to add some sort of I don't know what this padding is doing. Oh, it must have to be sequence dimensions must have to be divisible by 8. I don't know, but okay. Batch um, sequence dimensions need to be padded, but anyways, it seems like it needs to pad it. Mm, What? Pretty big, reasonable size transformer anyway. Oh, here's the Mllama vision encoder. That's actually what this guy was saying here, right? So, Let's do this. Looks like a pretty standard transformer. Um, Anything weird? Let's see. Okay. It has a little bit of funkiness, but I get it. It's like some sort of sign. It's fine. Hidden state. So I would expect it to be the same batch size sequence. Yeah. Oops. Um, Self-aware known toast. What's this doing? Same, right? Does it- all that tiling stuff is confusing to me. Okay, let me think. So, um, Oh, okay. Yeah, because if you have, mm, oh, okay, there might be some stuff there. So tiling, okay. I don't fully understand that, but I get the thrust of it. Basically, it's tiling so that it keeps, it can work on multiple images sizes. Well, I was just kind of thinking we're having one image size. Um, so yeah, but I guess if you have like a small image, then you can just use one tile and keep good resolution. So there's like a few different stuff there, but pretty global. Oh, it is gated. Huh. Okay. Hmm. State pre, hidden state post. Yeah, okay. Quite concerned about the padding. Padding, hidden state, reshaped. I think for some reason it looks like we're adding the num tiles back. Select intermediate outputs from encoder output. Layer indices. Okay. Okay, that's from the so it must encoder states, hidden states. Is that a list? I think it's I don't know what those brackets are in Python, but I'm guessing this is a list, like just a list of all of the hidden states. Or not all, maybe all of them. Well, shape doesn't have a shape, right? No shape. It's a tuple. But yeah, it's the yeah. So I guess we can loop through a tuple. Uh, this isn't gonna have a shape. So do this. We get new shapes. Right. So if I had to guess, that would be it would basically be the hidden state, or I don't know how we stack it. But so each of these intermediate layers is going to be this hidden state. Okay, yeah. So we have Stay reshaped. So yeah, it's this shape. It's basically each layer outputs, and then it looks like we have five. Um, we grab the from five different layers. Is this that what this guy's seeing too? They rework this on it. One, two, three, four, five. So it looks like this might be a little bit old and they made their logic a little bit better. Same thing. We have so we have the outputs and then global transformer, the 8-layer global enters a two key architect. But we've already passed here. This is all these hidden states are from the non-global. We have already gone through the global transformer with the final hidden state. Okay, so that's kind of weird. So we're going through additional layers, and then we have all the intermediate hidden states. Remove padding from intermediate hidden layers. Okay. Concatenate final hidden state. Okay. Let me just make sure. So remove the padding, and then we reshape it to the patch dimensions. And then so we reshape it to whoa. So each hidden state, let's say match. Oh, that's weird. Yeah, I guess it's not too crazy. So we have So each here in the hidden state, after it's passed to the full model, we have 10,025 patches basically, times four really, because so each one of the tiles, there's a four tiles, is patched into 1025, and each patch is 1280 dimensionality. First of all, what's 32 times 32? Plus the 25 is from the, it would be 1024 with 32, but we have a class token popped on. Um, so the intermediate hidden states, the we had five of them. So this number, the dimensionality is just the five hidden states, all their dimensions, I guess, concatenated. So 12 times 5, which to me is a little weird. I also don't understand how you can be able to concatenate. Oh, you can concatenate though. So that's crazy. So we take the five intermediate states, we concatenate them. It's the only dimension you could concatenate. And then it looks like we take the last hidden dimension, the global one, and we concatenate that as well. Okay. So that's crazy. So this hidden state will be 6,000 or whatever plus. So that's so weird. It'll be 640 plus, yeah, the other 1280. So it'll be 760, which looks like is this one right here. So this is the 760 is the dimensionality of each patch, which is pretty big. So we haven't summarized stuff yet, but that is a big a patch. That is a big patch. A lot of dimensions for a patch. And basically it this information will have it'll be five, six, it'll be like six, almost six different representations of the image, or at least layers of processing. So it's interesting. It'd be kind of better. I wonder if it'd be kind of better if it was like processing it at different resolutions. And because the transformer processes everything at the same resolution, but it's okay. That's neat. I mean, before concat, it will be that. If output hidden states, global attention, if global. Last hidden state, hidden states. Okay. What was my patch embed shape? Um, so this looks like a pretty standard patch embed. We go from 448 image to 32 by 32. So 448 divided by 32 is 14. So 14 times. So this will be a 14 by 14 patch. Each patch has 196 pixels. Um, we're going, each patch has 196 pixels. We're going to 1280. So what is this times 3? 588. 1280 is, over. So the dimensionality is plenty because basically, generally speaking, I think you want to have more than the total pixels and the RGB value. So it's 3 times, basically 14 times 14, 588. So it's like twice as large. So it can definitely hold. So that's fine. So the concatenating everything at different layers is interesting. I don't know about these gated information, but to me, this gated stuff all seems a little extra fancy. I mean, you already have the hidden features at 5 different layers, and so then basically like this, we have the final layer plus some fanciness. I don't know, that's concatenated. So yeah. So the only big problem I see here is the patch size is 32 by 32. Um, right. So just make sure I'm not crazy. And I feel like we need at least 64 by 64. And we probably really need 128 by 128 in order to get the high. get the appropriate positions to click. Maybe not though. That would be interesting. I wonder if I could just add positional information directly to an image, like a screenshot. Um, I can just add it in the RGB channels. I have two thoughts. So we just add it directly to the 3-channel original image. Um, so it'll be shaped 3 by 1920, 1080. We just add like sinusoidal or whatever positional encodings directly to it. The other option would be um, concatenate uh, positional information, or do like you could do like a linear. Um, prior to hatch embed. Finally, we could 32 positional. Does this help? I don't think it's. My concern with this is it'll very likely mess things up. This might actually work, especially if we control the scale of the positional information so it doesn't overwhelm the image. I think it could work. Um, Wait a second. Yeah, so we just downscale the image embeddings to a text. It's a big way to, it's a hefty, yeah, but basically every patch of the image we just we linearly project to 496 dimensions from the 7,000 or whatever it was, which is fine. Also, this should probably not just be a linear layer, but like probably a little MLP. So curious if they changed that since they haven't. This isn't going to get called yet. Yeah, this all seems pretty. The only thing about this whole thing that is I found a little bit odd is just that global attention, that global head uh, that has the global transformer that just like processes it with gated attention and then gets concatenated. It feels like we could have just concatenated the last layer without that and maybe work as well, but I don't know. Uh, I don't know. So the other option is we could, I don't know. We have some options here. So language things before sharing with the hidden size for it. How art stand self damage across those. Yeah, so that's fine. Not every layer does the cross attention. So the other branches appears every 5 layers at 3, 8, 13. So creating regular checkpoints version can influence text generation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, it integrates the cross attention at every 5 layers, which seems fine. I guess probably would work a little better if you did it every layer, but maybe it just will save some processing and you don't need to do it every layer. This is the type of thing where I'd probably just do it every layer, but fine. We could guess that the language model self-contained is directly loaded from Llama 3, bridging the integration side here. Um, that's what I just looked, right? Isn't that what I just looked at? I don't know why this guy's so, I don't know why he's so much history. Okay, yeah, okay. Okay, the cross section layer, I don't imagine. This is pretty obvious. Like, yeah, the queries, keys, and values are even gateway. I'm not sure about this gating mechanism, but yeah, this is just standard cross attention. So you have the when you're doing, and there's probably ways to remove this, to be honest, but basically, yeah, the queries are just the text and the keys and values is the image. So the image basically, yeah, feature reuse, features of costume system layers, visual features. Although so those visual features aren't further processed by they're not further processed, right? Cross attention states, key value. Text model. States. Okay. So this is what I'm trying to figure out. So decoder layer. So we never update that cross attention. It's not processed in any way. Because you could process it, but I guess it's fine. You could do, but that's fine. That's fairly simple. So you're always using the same image representation with the cross attention, which is probably fine, especially given that we have, it's a pretty robust representation. I kind of like that. Keeps things simple. Yeah, here's a good output. Local output. We have 5 of these. Concave multimodal projector. That's a fancy way to just saying we downscale it with a linear layer, vision output of everything. Yep, this is a very good. And I don't think this guy created this. So yeah, the only thing that I find unique is this using this 8-layer global vision encoder, and I don't know why they call it a global vision encoder. I mean, this is just the only thing that's different is it's using some sort of gated mechanism, and this is not. But I guess part of it is we're from the 32 layers, we're snagging various layers and concatenating it. And the global layer is just the final. So, yeah, I don't know. And we're also using gated stuff. So, yeah, I don't know. Uh, Presumably they tested out the architecture, but yeah, it's handy. It's okay. Yeah. Well, I understand that now. I don't know what good it's going to do. Well, it is actually good because it helps you understand how to, work with things. I bet it could get okay with positional information. The key is always it definitely could. I could definitely could get the positional information, but the key is to not break the current model so much, so it retains a lot of its current functionality. So when I fine tune it, actually, it just improves it. I like the idea of adding a little bit of positional information just to the RGB values. Because then when you patch embed, and maybe I could add honestly, you don't even need to do that. You just pipe through a big transformer. I mean, just a little bit of information, and now each patch will contain spatial, basically higher resolution spatial information is the way I would think about it. Oh man, I think that could work. The other option is maybe to add relative to each patch. So, make work. All right. Well, I'm going to call it for now. But basically, we have an understanding of the Mllama vision encoder, and big thanks to this guy who did, he kind of like helped me. I went through it myself too, but very helpful overview. This is the image that here's the image that is the important piece. Um, Patch embed, pass through 30, a simple transformer with 32 layers. We snag 5 of those layers, the hidden output from 5 of those layers. We concatenate it. We continue to pass through another 8 layers, basically. Those 8 layers have some fanciness, some gated fanciness to help information flow. We take the output of that, concatenate that. Uh, the dimensionality is a little bit higher than the 4,000 that is used by um, the model, the 4,000 dimension model that the words use. So we linearly project it um, from like 7,000 to 4,000. We then to integrate that information in the Llama 3 attention layers. Um, it'll do a regular attention, and then one layer will every 5. I think there's 40 layers total, and then every 5th layer has cross attention, and so the query is just the tokens, just the word tokens, and you cross attend it to the image representation, same image representation at every layer. Then it outputs, and I guess this works okay.